In topic 2, we're going to find some function values. So we're going to use symmetry to find locations for any point in the unit circle, which means we can also find the trigonometric function values and their equivalent angles. So we want to find the trigonometric function values for each of these angles using coordinate points in the unit circle. First of all is pi. Okay, so for the ones that are easy to draw, I'll just draw them instead of pulling up my unit circle page. I know where pi is. It's right over at the ordered pair -1, 0, and since I know that the sine value is the y coordinate of the ordered pair, that means the sine of pi is 0. All right, now the cosecant. All right, so 3 pi over 4. The pi over fourths are also easy to draw, so let me draw this one. The pi fourths on the unit circle, 1, 2, 3 pi fourths. It is the 3/4 mark to the pi. So right here, and I know that it's going to be a √2/2 pair, and the x-coordinate is negative, so this ordered pair should be -√2/2, positive √2/2. Okay, you can look at your unit circle to confirm that. And then the cosecant. Remember that the cosecant is going to be 1 over the reciprocal function, so 1 over the sine of 3 pi fourths. And so I know that the sine of 3 pi fourths is, again, the y coordinate, so it's positive. And so I have 1 over square root of 2/2, which is the same thing as 2 over the square root of 2, which rationalizes into 2 square root of 2/2, which is just the square root of 2. So I have the square root of 2 for the cosecant value. Now, it's important that we do the ones that are on the unit circle by hand because we don't want the decimal value for their answer. We want the exact value for their answer. I could, of course, type in something like this into Desmos, and I could get the decimal value for it. So cosecant of parentheses, I'm in radians still, so 3 pi over 4, and I do get some lovely decimal, which happens to be the same thing as the square root of 2. So I don't want the decimal value for it, I want the exact value for it, so we're going to use our unit circle to manipulate this. I'm going to flip back over to my unit circle for a second just to confirm how I would read this one. I was looking for the 3 pi fourths angle, so it's over here where I drew it, and I want the sine, so I choose the y value. It's a positive square root of 2/2. So if you have your circle memorized, you can draw that portion of it without having to look it up. You know the answer, and so then you can plug it in. Okay, so I'm going to do that again for the next one, and then we can also confirm with our unit circle page. So the tangent of negative pi fourths. Okay, so unit circle, negative pi fourths is a pi fourths in the negative direction, so a quarter in the negative direction. And I know that the pi fourths are all going to be √2/2s, and so since this one is in a quadrant where x is positive and y is negative, this is going to be x is positive, I said, and y is negative, so √2/2, negative √2/2. Now, how do I read tangent off the unit circle? Okay, so in the unit circle, since those are the x and y coordinates, I know that, let me take this little triangle and make it bigger. I know that the x coordinate is positive √2/2 and the y coordinate is negative √2/2. And that's my angle right there. In tangent, instead of having to use just one of those two values because the hypotenuse is 1, it's that value divided by 1, I have to divide those two values, right? I have to divide the opposite by the adjacent. And so it's a negative square root of 2/2 divided by a square root of 2/2. And so it's going to be -1, okay? So the tangent of negative pi fourths is going to be -1. But that's important to note. No matter which angle I have, if I want the tangent, since it's the opposite, that's the y value, divided by the adjacent to the x value, I can still use the ordered pair. So the tangent of any angle is the y value divided by the x value. I believe that that was written for us on one of our first couple pages in this section, so keep that in mind. I can find any of them if I have just x and y, it's just a sine and cosine, but any of them, right, I can find with the ordered pair right there. Okay, So it's the y value divided by the x value. Excellent. And again, on the unit circle, we see, we don't see it saying negative pi fourths, but if I go pi fourths in the negative direction, it's going to be coterminal with 7 pi fourths. And so I do have negative square root of 2 over 2 divided by positive square root of 2 over 2, which is negative 1 for the tangent. All right, the secant of pi halves. I like to draw them first just because it's helping me practice my memorization here. So my unit circle, pi halves, that's up here. Okay, and the ordered pair for pi halves is going to be 0, 1. Okay, now I don't know secant in terms of this, so I need to have, I like to memorize its reciprocal function. This is 1 over the cosine of pi halves, 1 over the cosine of pi halves, because secant and cosecant are reciprocal functions. And then the cosine is the x-coordinate. The x-coordinate here is 0. So this is going to be 1 over 0, so it's going to be undefined. Now, if you're not quite ready to have those reciprocal functions memorized, if you do go back to the beginning of this section, we can see that secant is again 1 over x, because cosine is x. It's the reciprocal function. It's 1 over it. So you can use this to refer to as well if that makes us a little more comfortable right now. So it is 1 over the x-coordinate. The x-coordinate was 0, so it's undefined. Okay, the cosine of 10 pi. 10 pi is not labeled on the unit circle, so I need to draw it. 10 pi is going to, we go around 1, 2, 3, 4, 5, 6. Pretend I drew a whole lot of times. 7, 8, 9, 10. It's even, so it's going to add a couple circles right there, spinning all the way around. It's going to come back where 0 and 2 pi are. So it's going to be on the unit circle right here at the ordered pair 1, 0. It makes sense because when I spin around, it's like 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, right back to that same point. So the ordered pair is 1, 0. I want the cosine. The cosine is the x-coordinate, so it's going to be 1. So the cosine of 10 pi is equal to 1. And the cotangent now of 5 pi halves. Where is 5 pi halves on the unit circle? So if I count my pi halves, I have 1, 2, 3, 4, 5. So if I go all the way back around to this point up on top at 0, 1, I have the angle 5 pi halves. 1 pi halves, 2 pi halves, 3, 4, 5, right? Counting halfway to pi each time. Again, you're not going to see 5 pi halves on the unit circle. You just see pi halves, but it's coterminal with that angle. All right, and then the cotangent value is the reciprocal of tangent. So instead of it being y divided by x, it's x divided by y, and so it's going to be 0 divided by 1. So the cotangent of 5 pi halves is the x value divided by the y value, 0 divided by 1, which is 0. Can't have our zeros in the denominator like part D, but they can be in the numerator just fine. So the cotangent is 0. All right, our note down here says, just as with degrees before, we can find the value of any trigonometric function for any angle using our calculators, provided that it is set properly. So always make sure that you check that you are in the mode that you want it to be, whether it's degrees or radians. So in example 5, find the trigonometric function values out to 4 places for each of these. We will use Desmos. So the first one we're going to be finding, I'm going to just double check that we're still in radians. Good, we're in radians. And the first one that we want to find is the sine of 11.7. And so that measure is negative 0.7619. Ooh, it's 198. So if I wanted to 4 places, really, I would have to round that to negative 0.7620. So it's at 4 places, so that's to 4 places. The other one was to 5. All right, and the cosine of the next one. So this is the cosine of the angle 2016. That's quite a few times around the unit circle there. This is going to be 0.6197 if I run it to 4 places. And then the cotan. All right, so again, if I, let me think where my calculator might be. I'm going to pause. I think it's in a different room. Alright, I grabbed my calculator because I wanted to show you how much different it is to do this on the calculator versus on Desmos, but we will do Desmos first. In Desmos, if I want to do the cotangent of 7 pi, I type the cotangent of 7 pi. It looks like it's undefined. Okay, so I do undefined. And I can just evaluate it on Desmos because I can do the cotangent. I can do all 6 trig functions on there. I cannot on the calculator, so if I wanted to do it on the calculator instead, I would have to type in the reciprocal function is tangent, so I would type in 1 divided by the tangent of 7 pi, but I got to change my mode first because I'm still in degrees, so make sure my mode is in radians, and then I can change this and do this input, and I get, I don't know, hold on. I may have to double check that I don't need parentheses here. 1 over the cotangent of 7 pi, coming up undefined in radians, coming up, and my calculator differently. This is scientific notation. Oh, for huge. Never mind. I thought it was small. I thought it was saying this is 0. This is actually huge. So this is coming out, I don't know how to say this in a word because it's much bigger than millions or billions, but coming out as a very, very, very large number. So what's happening here is that there is a vertical asymptote, so it is undefined. And so my calculator is actually failing to evaluate it. So bad job, calculator. The Desmos was able to evaluate it. The calculator gave me a very, very large number, which is actually not correct. It truly is undefined. It's trying to go infinite. My calculator didn't do good. So we're going to not use this thing. It's not behaving well. So it really is undefined. Now, we're going to prove it to ourselves because we got that weird answer. Why is it undefined? All right. So cotan of 7 pi. 7 pi, where would that be? So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi would be right over here. So the ordered pair is -1, 0. And if I do the cotangent of that, then we want the x over y. So -1 divided by 0. It is undefined. Okay, so it definitely should be undefined, and we will be happy that Desmos gave us that, and we'll be upset at my calculator for doing something weird.